Hello students, this is just a continuity of the previous video. As I had some technical issues with the memory, I had to make a separate video for this. Okay, very quickly we'll continue with it. The properties of equipotential surface. We have already discussed two properties. The next property is electric field must be perpendicular to the equipotential surface. Okay, suppose this is an equipotential surface. Okay, suppose this is an equipotential surface, then the electric field should be in the direction this. Okay, if this is an equipotential surface, electric field must be in this direction. Okay, now let us understand how we can do this. Suppose we know formula, change in potential is equals to E dot dr. Okay, where dr is in the direction of potential field. Okay, suppose this is an equipotential surface. If this is equipotential surface, then change in potential will be equal to 0. So d0 equals to dv E dot dr. Now this is a dot product, so if you remove the dot product, it will be E dr cos theta. Okay, will be equal to 0. Here you can have two conditions: either electric field has to be 0, either cos theta is equals to 0. If it is if electric field is not present, that is electric field is 0, there is no use of this. Okay, so there is some electric field present over here, so only condition that is left is cos theta equals to 0. If cos theta equals to 0, then theta will be equal to 90 degree, which means E and dr are mutually perpendicular to each other. Okay, dr will be in the direction of these points anywhere. Okay, so it shows that equipotential surface is always perpendicular to the electric field. Okay, let us look it with some another example. Suppose I have a point over here. Okay, this is a point charge Q. Electric field lines are in this direction. Okay, now from the definition of electric field lines, or in the properties of electric field line that we have previously studied, we know that this is always perpendicular to this surface. Okay, so here also you can know that this is our equipotential surface, and this is our electric field lines. So this will always be perpendicular to each other. Okay, if taking the example of cylinder also, suppose this is a line charge, our equipotential surface is this, and the electric field line coming out will always be in this direction. So this will always be perpendicular, which says that electric field lines and equipotential surface both will be perpendicular to each other. That is always. Okay, must be electric field must be perpendicular to equipotential surface. Okay, I hope this property is very clear to you. Then we shall move towards the next property. Okay, what does the next property say is fourth one, two equipotential surface can never intersect. Okay, now suppose we have two, let us assume that there are two equipotential surfaces which are intersecting each other. Suppose this is one of the surface. Okay, suppose we are having another surface that is intersecting with the same thing. Okay, now these two are our equipotential surface. Okay, now the electric field produced due to this surface. Okay, this is an equipotential surface, and in the previous property only we have studied that electric field must be perpendicular to the equipotential. So this will be the direction of electric field at on this surface. So suppose, let us take at the point of intersection, the electric field due to this, let us name it as 1 and this as 2. So the equipotential surface electric field due to equipotential surface 1 will be in this direction. Okay, now for this plate, okay, for vertical, that is 2 plate, the direction will be this, because it needs to be perpendicular. So at this point the direction of electric field will be this also. Okay, so what is happening over here, at this point we are having 2 directions of electric field. At the point of intersection there is 2 directions of electric field, but this is not possible as per the properties of electric field lines or electric field. It is not possible that there are 2 directions of electric field at a single point. So if the two equipotential surface intersect, there will be 2 directions of electric field, but which is not possible. So 2 equipotential surface can never intersect each other. Okay, I hope you are getting it. Now we can say potential goes on decreasing as we move in direction of electric field. Okay, we have already studied that whenever we want to bring anything from infinity, okay, at infinity the electric potential is 0. When we are bringing it, the electric potential always keeps on increasing, which is opposite to the direction of electric field. Suppose here that is 10 volt. If you are going away from here, this is, let us say this is infinity point, again you are going over here, what will happen? Here it will become 8, and so on, it will keep on increasing, it will keep on decreasing. We have studied this in circular form also. Suppose this is our point Q. At this point, if it is 10 volt, here it will be 8, and so on. If we keep on increasing the diameter as we go away from the source charge, the equipotential, the potential on the equipotential surface goes on decreasing. I hope the properties of equipotential surface are very clear to you. And last, a very small topic, we will continue in this lecture only. We'll just draw the diagram. Equipotential surface due to a dipole. Okay, I hope everyone is aware about the dipole. Dipole is 2 equal and opposite charges. Okay, now instead of starting with equipotential surface, what we do, we know what is the direction of electric field. Electric field goes from positive to negative. So suppose if the electric field lines comes out from here, it will end over here. Okay, this way. Okay, similarly this way, this will be the direction. From positive charge, it will always come outside. Okay, in this manner, okay. Here it will go inside as it is a negative charge. Okay, so now we know that electric equipotential surface is always perpendicular to the direction of electric field line. Okay, so at the center you can assume that there is a straight line which is perpendicular to all these surfaces. Okay, perpendicular to all these surfaces. Then what? If this is a curve, you need to have a potential that is always perpendicular to this surface. So there is a curve which will be perpendicular to all the surfaces. Similarly, as we go move ahead and come nearer, it will have this type of arrangement. Okay, I'll draw it in a simple form with not much of a electric field line so that you can easily understand. Plus Q minus Q. This is electric field line. Okay, only to show over here this will be perpendicular, over here also it will be perpendicular. Okay, so if we go on for another field lines also, it will make this kind of it will be circular form. It will form the circular thing. In the center it will be a straight line. Similarly, as it is on this side, it will be on this side. Okay, so simply the thing is, you need to have a equipotential surface that is perpendicular to all the electric field lines. So here it can be in this way. Your book has given it in this way. Okay, here it will be small circles. Okay, I hope this is very clear to you all. Okay, that was it for the properties of equipotential surface. We'll study now. Next will be potential energy. The video of that will be uploaded very soon. Okay, till then I hope you all are studying and complete this theory so that I can give you the further videos. Thank you.